Alright, the problem I'm going to do for day 2 on 2.6 is this particular one. It's graphing 2x to the third plus x squared minus 8x minus 4 over x squared minus 3x plus 2. And this one, because the numerator's exponent is larger than the denominator's, this one has a slant asymptote. So like I mentioned on day 1, you have to be able to identify when you have a horizontal asymptote, and then day 2 when you have a slant asymptote. So because I see the slant asymptote, my first step isn't to factor. That's what it would be if I had a horizontal asymptote. My first step here is to actually go ahead and do the long division. So I'm going to take 2x to the third plus x squared minus 8x minus 4, and I'm going to divide it by x squared minus 3x plus 2. So your steps are a little bit different. They're similar, but a little bit different. Going to go ahead and do my long division. It looks like I'd have to multiply this term by 2x to get 2x to the third. So 2x, distribute that 2x to get 2x to the third. That would give me minus 6x squared, and that would give me a positive 4x. Parenthesis around the whole thing. Remember, I'm subtracting, so careful with double negatives. First terms cancel, they're supposed to. This is x squared minus a negative 6x squared, so it's going to turn into a positive 7x squared. Negative 8 minus 4, so negative 12x, drop down whatever I haven't used yet. Degrees are the same, so I've got one step left. It looks like I'd have to multiply by 7. Redistribute the 7, I get 7x squared minus 21x plus 14. Again, quantity subtracted. First terms cancel, they're supposed to. Again, careful with the double negative. This is going to give me a positive 9x and minus 18. So this original function could be written as 2x plus 7 plus, the remainder was 9x minus 18 over, I originally am dividing by x squared minus 3x plus 2. So all I've done is I've taken this function, they've given it to me as a kind of like an improper fraction, and I've rewritten it as more of a mixed number. And then if you remember from class, this is your slant asymptote. And this is where you're going to find your vertical asymptotes. You obviously don't have a horizontal asymptote because you have a slant asymptote. But this is where you would find any vertical asymptotes, any holes. You check to see if it crosses and so on. So I'm going to go ahead and start to factor this. So first step, we did the long division to get the slant asymptote. Now I'm going to factor the remainder to see, do I have a whole vertical asymptote? What do I have? I can see the numerator, it has a 9 in common, so I factor that and I get 9 times the quantity x minus 2. The denominator, if I factor that, I end up with x, I guess that is x minus 1 and x minus 2. And so I can see that they cancel, so I do have a whole. So when I start listing off my information, I'm going to say that I have a whole at x equals 2. This is my remainder now. So my vertical asymptote, I only have 1, is at x equals 1 from this. Horizontal asymptote, I don't have one, but I do have a slant, and my slant asymptote is y is equal to 2x plus 7. And now I'm going to ask, does it cross the slant asymptote? Because it's possible that it does. And how I do that is I take the simplified remainder, which was 9 over x minus 1, and set it equal to 0. Always set it equal to 0. Again, that's a little bit different with the horizontal asymptote. If this was a horizontal asymptote, I would set the remainder, or I would set my function equal to the horizontal asymptote number. Slant asymptote, a little bit different step, so be careful with that. Alright, so I've got that set up. Set that equal to 0. If I cross multiply, I get 9 equals 0. I don't even have a variable left, so does it cross? No, it does not. If you cross multiplied and say you had an x left up there, then of course I would get x equals 0 or x equals whatever, and that's where it would cross. So I've got all the information that I need. I can now go ahead and set up my graph. And so again, I'm going to do that. Slant asymptote tends to make this a little bit messy. Because my slant asymptote has a y-intercept of 7, I'm going to want to make sure that I go up at least 7 And realistically, I'm going to probably want to go up more. You're going to see how messy this gets here in a second. All right, so vertical asymptote at x equals 1, that is right here. And since I don't have room to kind of label it here, I'll just label it down below that x is equal to 1. All right, slant asymptote is 2x plus 7. So 1, 2, 3, 4, 5, 6, 7 is the y-intercept. Slope of 2 and over 1. So here is my slant asymptote. And if you want to label it, you can. I don't necessarily require you to label this one. Alright, and then I'm going to go ahead and do my little test regions again. I only have 2 regions to test. I have everything to the right of 1 and to the left of 1. I don't want to pick that number. Now, what do I plug it into when I do my test points? You know, when we did the horizontal asymptotes from day 1, you plugged it into the simplified equation. I don't do that for this. What I plug it into is I plug it into the simplified remainder, which was 9 over x minus 1. And all I care about is this a positive number or negative number? Positive number would mean it's above the slant asymptote. Negative number would mean it's below the slant asymptote. So a little bit different. Like I said, there's some similarities but some differences. So I'm going to pick a number to the left of 1, and I'm going to pick 0. And if I plug that in here, I'm going to end up with 9 over 0 minus 1. Really all I care about is if this is positive or negative or not. It's a negative number. So I know that it's below the slant asymptote. I'm to the left and below. I'm in this little window here. So my curve looks something like that. And now I'm going to pick something to the right of 1, like 2, and pay attention to is this positive or negative. And it ends up being positive 9, if you want to be exact. All I care about is it's positive, so I picked a number to the right of 1. It was above the slant. It's up in this little region here. And then the only thing I want to make sure of is pay attention to the hole. There's one at x equals 2. X equals 2 is right here. I'm going to go ahead and put a hole there. And there's my graph. So make sure that you spend some time reviewing the steps for what to do when you have a horizontal asymptote and the steps for what you do when you have a slant asymptote. They're similar and yet different, which can make it even harder because there's some similarities and differences. Hopefully that'll help you out with some of your homework problems. If not, go ahead and feel free to come in and ask for help.